Hello, everyone, and welcome to another Into the Terminal. Today, we're going to be talking about disk I/O schedulers. When we start talking about performance tuning, realize that there's a lot of really smart people that do Linux. They are kernel developers and do I/O schedulers and all this other stuff. So generally, the out-of-the-box defaults work pretty well, which means there must be a reason why the out-of-the-box defaults are not working for you, or you want to change them. And typically that's because you know your workload and it's very specific and has specific criteria. And so you can optimize what happens because you know what's going on your system. And so you can make those fine grained changes to tweak things a bit to make it better for your specific workload. If you don't know your workload, don't mess with it. Because how do you know what to change and what values to change and what could actually be bad if you don't know what to expect, right?
If you don't know your workload and you're having performance problems, you shouldn't just randomly change disk performance settings to see what happens.
You could, but realize that you could make things very much worse.
Yeah.
All the changes that we're going to be talking about are in memory. So if you were to go that route and just start twiddling all the knobs, you could reboot the machine and get back to what it was by default. The other thing that you need to be attentive towards is while you might know how your workload works now, maybe a software update to your workload software or a change in something changes that. And that means that you need to constantly kind of reevaluate whether these are the right settings for you. And then how much are we really going to get out of it, right? I think for performance tuning things, if you get 5% improvement, you're doing pretty good. So we're talking about really small amount of changes that if you're doing millions or billions of transactions, 5% is a lot of numbers, right?
Right.
So that might be worthwhile. But if you're not there, maybe it's best to just trust the Linux experts and take the defaults. All right, why don't we jump into doing some terminal-y stuff. For all your disks and the tunables that we're going to about to talk to, they actually live in kernel RAM. So every time the kernel is booted on the machine, it gets a fresh copy of this kernel memory. And you can make changes to what's stored there and realize that when you make changes there, they'll be immediate. And so we could do something like look in sys block. And you notice that I have two disks, SDA and SDB. You can actually make different tuning changes to individual block devices to make them behave differently, which is kind of cool. Main disk is SDA. Go ahead, Nate.
I said, yeah, that's good, right? Because a lot of times a workload maybe will use a specific disk for a specific use case, right? So you can tune that disk to that workload versus the entire operating system that maybe doesn't need the tuning.
Right. So down here in the sys block SDA, these are all the things about this specific device. We see things like its size, whether it's removable or not, and a bunch of other stuff, its partitions. But what we're interested in today is Q. Because Q tells you your I/O settings for your I/O queuing. And so there's some parameters, and we'll take a look at a couple of these later on the show. But for disk scheduler specifically, it's in the file called scheduler. So instead of listing it, I'm just going to cat it. All right, so these are the 4 disk I/O schedulers that come with, in this case, Red Hat Enterprise Linux. And these are built into the kernel of the operating system. The one in square brackets, that's the one that's currently selected. So Nate, which one is currently selected on this machine?
Wow, I didn't think there was going to be a test here. None is selected.
We'll talk about which ones you select and why ones get selected by default after the transition as we get into the deeper dive. But so none is we're not doing any disk I/O things. MQ deadline is another really popular one to use. And so if I wanted to switch this disk to use MQ deadline, I would just echo MQ deadline into that file. Right? And now we can see, thanks to the square brackets, our scheduler has switched to the deadline scheduler.
I really like how this text file works. I'm just going to say that, like, or not text file, I should say. This interface into the kernel works.
Yeah.
I've seen a lot of them that do not make it nearly this easy to tell where the setting is set. It's like 0, 1, 28. Okay, what does 28 mean?
All right, the other two we have to choose from are Kyber, and I'll show you a quick thing on Kyber. It's not heavily used across the industry. And then the other one is fair queuing, or BFQ.
In
So
order to use Kyber, do you have to go and harvest your own crystal and then build a lightsaber around it?
that's only if you're making lightsabers. But
Okay.
for Linux, no, you can just use the Kyber scheduler. And so
Oh.
if you want to use one of these others, like BFQ, you could echo BFQ into the scheduler file, right? And now BFQ is selected. So these things happen immediately, right? Because we're tweaking the in-memory kernel settings of the system. It happens immediately. All right, so I'm going to switch back to deadline. All right. Because these are in-kernel changes, if I was to reboot the machine, I'd be set back to none because that was the default for this machine. So the way that these are set permanently is through a daemon called tuned. And on RHEL boxes, tuned starts up every time. If you're not using Red Hat Enterprise Linux or a Red Hat derivative distro, you may need to use something else, like a startup script, to make these changes every time the system boots. But for Red Hat distros, we use the daemon called tuned, which should be turned on by default. And so what we're going to do is we're going to make a new tuned profile. And before I start that, I'm going to look at what my existing tuned profile is. All right, so my current profile is virtual guest, which is a profile selected for machines that are virtualized systems. So if they're VMware guests or Hyper-V guests or OpenShift Vert guests or cloud instances, they'll get this tuned profile by default. And so the tuned profile virtual guest is actually what set that none scheduler. So if I just leave it as it is, when I boot the machine again, I'll again get virtual guest and I'll get the none scheduler. So what I'm going to do is I'm going to create a new profile that's unique to this system that I could then copy to other systems if I have a batch that I want to do the same way. And I'm going to make a new tuning profile directory in Etsy.
Now, speaking of virtual machines, this disk tuning could get weird, right? Because you have another layer of operating system underneath your disk here. You've got a virtual disk.
Yes. And so we'll talk some about that. And that's actually why the none scheduler is chosen by default for virtual machines.
Right.
And cloud
Okay.
instances. All right. So I'm going to create my own tuned profile called virtual guest mine. And it's going to have a tuned configuration file that says, here's what this profile should look like. Right. And in my main setting, I'll do include. All right. So essentially how I'm setting it up is I want to base this one off of virtual guest. So all of the other swap space settings and other things that have been set for virtual guest, I'm going to get all those. But I'm also going to make the following changes. So after I apply all of those, I'm going to make these changes to the machine. So it'll start by applying all the virtual guest stuff, and then it'll apply any additional changes in the profile. In this case, changing my disk elevator to deadline. All right. And if I do a tuned ADM list, right, mine shows up in the list.
There you go.
And
so there's no reload of the daemon or anything like that required. It just
reads it on the fly.
Cool.
And I'm going to set it back to none, which was the default. There we go, right? So when I switch to my tuned profile, we should have all the other virtual guest things, except when I look at my scheduler, it should be automatically set to MQ deadline, right?
There you go.
Tuned will apply the last tuned profile to the machine automatically. So if I reboot the machine, because the current profile is virtual guest mine, then when it boots the next time, it'll get virtual guest mine. So that's how we kind of like boot the kernel, unpackage all of its default settings, and then apply these additional settings over top of it to remap some of the defaults. Right. So that's kind of the lay of the land. That's how you actually switch your scheduler and make it permanent.